Welcome back. In the previous video, we learned the two pointers pattern, where we used a left pointer and a right pointer to scan the array efficiently. Now, we take that idea one step further. Instead of looking at individual elements, what if we process a group of elements together and move that group forward? That group is called a window, and this approach is known as the sliding window pattern. Now pause for a second. Have you ever solved an array problem by looping through every possible subarray and felt like something was inefficient, but you were not sure why? That's exactly what this pattern fixes. Let's understand the problem. We are given an array and we need to find the maximum sum of any three consecutive elements. Consecutive means continuous, no skipping. In two pointers, we moved pointers to compare values. But here we are not comparing. We are calculating a value for a group of elements. So instead of single elements, we focus on a window of size 3. First group 215 sum is 8. Next 151 sum is 7. Next 513 sum is 9. Next 132 sum is 6. So the maximum sum is 9. But look closely. We are recalculating the same elements again and again. This repeated work makes the solution inefficient. Now here is the key shift in thinking. Instead of recalculating everything, we reuse previous work. Just like in two pointers where we moved pointers smartly, here also we move forward intelligently. From this window 215, we remove the element going out, which is 2, and we add the element coming in, which is 1. Now we get the next window 151. That's it. We did not recompute the full sum. We just updated it. So what exactly is a window? A window is a continuous chunk of the array with no gaps. It has two boundaries, a left pointer and a right pointer. So just like two pointers, we still have left and right, but now they define a range instead of individual positions. Now let's see how the window moves. We start with the first window. Sum is 8. Now we slide the window one step to the right. Remove 2, add 1, sum becomes 7. Slide again. Remove 1, add 3, sum becomes 9. Slide again. Remove 5, add 2, sum becomes 6. Notice something important. We never recomputed the full sum. Just one remove and one add. That's the power of sliding window. Now there are two types of sliding window problems. First, fixed size window, where the window size stays constant. Second, variable size window, where the window expands and shrinks based on conditions. In this example, our window size was fixed, so this is a fixed window problem. In brute force, we repeat calculations again and again, but here each element is processed just once. So we move from repeated work to a linear pass. If you remember just one rule, remember this. Remove what goes out from the left, add what comes in from the right, move the window forward and repeat. Now that you understand the idea, let's actually implement this. In the next video, we will write the code for the fixed size sliding window and solve the maximum sum subarray problem step by step. Once you see this implementation, you will realize how simple and powerful this pattern really is. And after that, we will move to the more advanced variable window problems. That's a wrap on episode 1. If this clicked for you, please hit like. It genuinely helps the channel grow. Subscribe for the full pattern series and drop a comment if you have any questions or want to see a specific problem covered. See you in the next one.